All right, welcome back everyone to the 5J5 studio. It's great to have you here. I am Parametric Phil, and this is episode, you know it's coming, episode 3 of Rhino Fundamentals. In this episode, we're going to start learning a little bit about how to create geometry. So in the last episode, we looked at different types of geometry. We started to define different types of geometry, and we learned some of the general terminology. But in this episode, we're going to learn a bit more about how to call up the commands that we need to, and how to read the different command options to generate the geometry that we're looking for. So let's just jump right into it. So if we want to create a curve, or let's start off with a line, a polyline. So there's a few ways we can do this. We can click on the Polyline tool. It's over here, the one with 2 line segments. Or we can type in Polyline. Or like what I like to do is I have a hotkey associated with Polyline because it's a command that I use very, very often. And we're often drawing polylines in the plane view. So we'll usually go to the top view, but you can draw it in any plane you want. And there's a few methods you can use to actually start drawing your line. You can start clicking, and if you have reference points, you can use those reference points to just click and make your drawing. Or you can go in here and you can start typing in dimensions. So I can just type in 100, and then I've locked in the dimension, and I can pick the direction, and then I can go 100 or 50. Okay, and then I can go 100, and then I can close it, or I can click close curve. So you'll notice that there are a lot of options up here that you can use, and it's always a good idea at every step, especially when you're learning, to look at what your options are, because a lot of the time there are a lot of really helpful options up here that will help you create your geometry a lot more efficiently. Okay, so one thing I want you to remember also, this is a little trick, is that there's a whole bunch of tools that will help guide you in drawing the geometry that you need a lot more efficiently. And I just did one of them. If we hold our cursor over that point, it will create sort of a construction line, or it'll create a snap, and now we're snapped onto that point. And now if I want to snap onto this point, if I want to make a box that's the same size or the same height, I can either do it like this. I can go snap to that. I can get one of those snaps there, and then I can do it like this. Or what I can do, which is faster, is I go in the direction that I want to go. I hit tab. I get this white line. Now that I've hit tab, the line cannot move in any other direction. So I just go there, and then I hit that point, and then I've got it. So that's the tactic I like to use. Use tab as much as possible. So I use tab again. Boom, white line, corner, done. Close polyline. Okay. So that's the basics of drawing the polylines, and I'm going to talk about the coordinate system at the end of this video, and that might be necessary. You're going to probably want to stick around just to get an introduction to how the coordinate system works. And I'm going to break it down. I'm going to make it really simple if you're not familiar. But before that, we're going to quickly go over a few other types of geometry. Okay, so when it comes to curves, there's a few other main commands that we're going to use. One of them is the control point curve. This might be also referred to as a NURBS curve. And unlike the polyline command, this doesn't create straight segments. When we create points, it will influence the direction of the curve, but the curve does not follow those points directly. So this is the best way to make smooth curve segments. Something like this. This is a periodic curve, meaning that there's no kink at the start or the end. So it's a closed curve, and it's periodic because the start and end points are perfectly tangent. Now, if we need to a smooth curve that follows a certain set of points perfectly, that intersects those points, we can go to the control point curve tab, and we can either hit this little arrow, or we can just hold, we can click and hold, and then we have this sort of sub menu that comes up, and it shows us a bunch of other different curve options, different control point or like kind of smooth curve options. And we can choose the Interpolate points curve. And what this is it's different than the last one that we looked at, because this curve will always intersect the points that we draw. So now it's important to remember that this is still drawing a control points curve. See, it's actually drawn the control points, and the intersecting points, the interpolated points, those are just to construct it. Now, the key thing here is that if you need a curve to be tangent, if you need a one of these curves to be tangent to existing curves, the easiest way to do that is to draw a control point curve and then get that tangent snap going. So draw one point, at least one point that's tangent, and then draw another point that's tangent to your end line, and then draw your final line. And so this is a tangent curve because these control points are tangent to the start and end segments that you're trying to draw tangent to. And if you want a smoother transition between the straight segment and the curve, you just have to draw more tangent points. This is a real oversimplification, and we'll probably get a little more into this in a later video. But you can see this is a lot smoother transition. Okay, but if we're using an Interpolate points curve, we're going to have to use a different process because it's not going to make the curve tangent. If we use that same process, it's going to look something like this. Okay, it's close, but it's definitely not tangent to our start and end points. So we have to use, we have to click on that Interpolate points curve, and we have to use one of these options right here. We have start tangent, so that's a really important. This is a point when this is a really important option. And now if we tell Rhino what our start tangent direction is, then we can start our curve, and it's gonna maintain the tangency. Okay, and then when we end the curve, we have to also tell Rhino what the end tangent direction is. So we can do something like that. Oops. There we go. Okay, so that's enough about control point curves, polylines. The main other curves that we're going to be using are circles. And when it comes to a circle, it's very simple. Usually we start at the center, and this is a center point, and then we can choose a radius. Let's say 50. But if you, this is actually a diameter. By default, it uses the radius. But if you want to work in diameter, then you can, that's one of the options here, diameter. And obviously it's going to be half the final size. And some of the other important options here are stuff like orientation. If we want to draw a circle on a vertical surface, then we can go into orientation. We can go vertical, and then we can put a circle here, and then we can draw it on a vertical surface. Otherwise, it will be locked to the X and Y plane. There's other options that we have in here. We can create a 3-point surface, or circle, and it's going to look for 3 points, and then create a circle based on those 3 points. So sometimes that's useful. So the key thing is that make sure you're looking in these options to make sure that you're building the circle in the easiest way possible. So here's another example, a tangent circle. I use this quite often. We can go tangent to this curve, tangent to this curve. And at this point, we can either go tangent to this curve and create that circle, Or sometimes we actually are creating maybe a fillet or something like that manually. There is a way to create a fillet automatically, but maybe there's a reason we can't, so we're creating a fillet, and maybe we know what the radius of that fillet is, and we can just type in a radius. So just different options. Make sure that you're looking through the options and making sure that you're drawing your geometry the most efficient way possible. So let's just push that a little bit towards surfaces and solids just for a minute, and then we'll just end off talking about the Cartesian plane system. So if we want to create surfaces, there's a lot of different ways we can do that. We can create planes like this. We can go to create a plane like this, like a rectangular plane corner to corner. And if we hold shift, then we're creating a square plane. And we have similar options up here. We have vertical, right? Just the same as we drew our circle vertical, we can draw planes vertical instead of having to rotate afterwards. When it comes to planes, we have lots of different options. We can create a 4-part plane like I showed you earlier, 4-point plane. If we have an existing, maybe we have a periodic control point curve, we can create a planar surface out of that. If it's not planar, if the curve is not planar, that won't work. And a little bit more complex version of that is we can create stuff like lofts. So a loft is an example of where we're actually using a control point curve, or we're using any type of curves to generate a surface in between two curve segments. So I'm making a curve, and I'm gonna draw another curve over here. And I'm gonna type in loft, and we can look at, there's no other options really here except to loft from a point, but we're just gonna select the curves of the loft, and we want to make sure that we select the curves on the same side of the curve, okay? And I'll show you what I mean. If we didn't do that, it would look like this, okay? Because it's trying to loft from this side of the curve to this side of the curve. And when it comes to curves, lofts, we can use more than one cross-sectional curve. Okay. And we have some options in some loft options. We can generate straight sections like this. We can generate a loose loft where the loft does not actually directly intersect the curves, but it's going to be a more gradual surface. We can create a tight loft that very tightly intersects the curves, or just normal. And we can rebuild it also to change the complexity of the surface. Okay. Generally speaking, we want to keep our surfaces as simple as possible. So I would just, generally speaking, I would say do not simplify, and you only want to rebuild it when you absolutely need to. Okay, so that's the basics of a loft. And you know, the other main one that you're going to be using if you're doing these types of surfaces is sweep. So let's say that we have a surface like something like this, but we want to have more control of how this edge, we want to have more control of what this edge shape looks like. So I'm going to use an interpolate points curve here because I want this line to intersect the points that I'm drawing perfectly. Okay, so this is a bit of a complex looking surface, so I hope this works. We're going to do a sweep 2, and sweep 1 is a simpler version of this. Sweep 1 is going to ask for one cross-sectional curve, but sweep 2 is going to ask for, sweep 1 is going to ask for one rail, and sweep 2 is going to ask for two rails. So it's going to ask, what is the first rail? The first rail is this one. The second rail is this one. And our cross-sectional curves are similar to in a loft. We're gonna select them the same way that we would select in a loft. And it followed it pretty well. So we have some similar options here. We can rebuild the curve. We can rebuild the sweep, depending on if it's, if we rebuild it to less points, we're gonna have a maybe a more smooth looking surface, but it's not gonna follow our cross-sectional curves as well. So yeah, that's the basics of sweep, sweep 2, and if we compare that to the loft, see how the loft had the edges took the shortest path, the most smooth path, and in the sweep the edges followed the exact path that we drew with our interpolate points curve. Okay, so that's kind of all I wanted to get started on with when it comes to surfaces. We have a lot of other tools we could talk about, revolve, things like that, but I just want to kind of walk you through the basic process that you have to go through when you're activating a command, looking at the different options, selecting the curves the proper way. Just want to get you used to kind of the general procedure. And the last thing really is that we can talk about is solids. And when we're creating solids, there's a few different ways we can do that. And we can create, say, a box, and all we're doing is creating a rectangle, and then we're defining the height of that rectangle. And now this is a solid. Now that's not the only way that we can make a solid. We have solid options when it comes to a box, or we have other things like a cylinder, sphere, cone. Okay. But similarly to how we created a surface from curves, we can also create a solid from a curve. So we have a curve that is a square, and now if we extrude curve, okay, now we have now we're defining the height just the same way that we created that box. But the key thing here is that you can choose whether you want it to be solid or not. Right here, solid equals no, solid equals yes. So this would be an open poly surface if solid equals no, solid equals yes. Now this is a closed poly surface. And this is the exact same result as the box command. But what this means is that you can use any type of closed planar surface or planar curve, closed planar curve, and you can extrude that and create a solid that way instead of having to modify your box. So that's the key thing there. Okay, I think we covered pretty well the general procedure of activating the commands that we need to start creating our geometry. But I just want to spend a few more minutes talking about the Cartesian plane system and talking about how we use dimensions and we actually input them into the model in the proper way. And there are a few different ways. So I'm sure you've noticed by now that you can just start clicking points to generate any type of geometry, and this is a tool that you will use often, but you can't always use that tool. You can use that tool if you're, let's say, like joining two surfaces or something. So you can use the points, the snapping points, if you have something to reference. But when you don't have a reference, you have to use different strategies to generate the geometry, the proper size, and in the proper location and orientation and all that, right? And that's when we get into the Cartesian plane system. And there's a few ways to use the Cartesian plane system, but let's just first cover what that means. The Cartesian plane system is a grid, basically, and it's a grid, and there's three coordinates. There's the x, y, and z. The x goes in this direction, and we can see that based on this red line here. We can also see that based on this icon right here that's always telling us the X, Y, and Z directions. And so the X goes this direction, the Y goes this direction, and the Z goes this direction. And we generally consider the Z to be the vertical axis. And in the Cartesian plane system, there's 3 different primary planes that we work off of. We have the X and Y plane, defined by the X and the Y. We have the XZ plane, defined by the X and the Z. And we have the YZ plane, defined by the Y and the Z. And these are the primary axes that we work off of. And of course we can rotate and we can work in any orientation that we want to, but this is just a reference. It's usually we build off of these planes, and we usually use one of these 3 planes as a reference point to how we build our geometry. So knowing that we have these 3 planes, let's just talk about quickly how to build on these planes. So when it comes to the Cartesian plane system, we can use either absolute positioning or relative positioning. And there's a few ways to go about both of those. And let's just quickly touch on absolute positioning, but really I almost never use absolute positioning, but you might use it depending on your project, and you definitely have to understand how it works, at least fundamentally. So if we're drawing a line in the Cartesian plane system, we have 3 coordinates, X, Y, and Z. So when it comes to a line is a series of points, and we have to define where each of those points are in the X, Y, and Z coordinate system. Like I said, if we don't have a reference point, so we can't just start clicking. If we can't start clicking, we have to know what that coordinate is. So we can start, if we want to make a box, a rectangle that's 60 millimeters long and 30 millimeters wide, and if we use the absolute positioning system, we can start at 0, 0, 0, so X 0, Y 0, Z 0. We can press enter, and so we've started at our origin point here. And now if it's 60 millimeter long box, we can type in 0 in the X, 60 in the Y, and 0 in the Z, and we can hit enter, and now we have our next point that's gone to that coordinate that we just typed in. And so we can just finish that off. We can go 30 in the X, 60 in the Y, 0 in the Z. We can go we can now go 30 in the X, 0 in the Y, 0 in the Z. And let's just close this box because I don't want to keep doing this. It's not a very efficient. It's usually not a very efficient system to be working in the absolute positioning, method. So typically, I'm either using single digit or single line dimensioning or relative positioning. So when it comes to relative, and those 2 methods are very similar. So when it comes to relative positioning, let's draw the exact same rectangle, but we started off at the origin 0, 0, 0. And when it comes to relative positioning, we're actually treating each successive point as if the last point was an origin. So each point is relative to the last point that was drawn. And to use a relative position, we hit the @ symbol, and then we put in our coordinates. So it would be 0 in the X, 60 in the Y, 0 in the Z. And now we have that line. So if we want to get to this point, instead of putting in the absolute position, which would be 30 in the X, 60 in the Y, instead of the absolute position, we're just going to do the relative position. And this is simple for us because all we need to know is that this is our point that is relative to this point. All we need to do is go 30 in the X direction, and that's it. So we can go at 30, 0, 0. It's very simple. And if we're only working on the X and Y plane, we actually don't even have to put in the Z coordinate. So let's just go back to this point, and we just go. All we know is that we need to go -60 in the Y direction. We don't need to worry about the absolute position. So we just go 0, -60, boom, and then we can go back to 0, 0, 0. Okay, so when it comes to the relative positioning system, it's going to be a lot easier most of the time. And so I can just define, if I want to get to this point, 10, 10, I can go 10, 10, which is actually the same as the absolute positioning system. But let's say I just want to go 50 millimeters in the y direction. So just go 0, 50, and now I want to go 40 in the x direction. I just go 40, x, 0, y, boom. And so it's a lot quicker to draw that way. Or we could, this is a very simple, very similar process. We can go, if we're only making moves in the x and y, we can just type in a dimension, say 50. We can, and then our curve is locked to that length, and then we can define the direction that we want our curve to go. So it's a similar process, but you would use that process when you're making lines that only go in the x and y direction, or but if you want a line to go, if you want a line to go 10 millimeters up and 20 millimeter, if you want a line to go 10 millimeters in the y direction and 20 millimeters in the x direction, you actually don't know how long that line is because of trigonometry, unless you're a crazy math genius. So in that case, you would want to go 20 in the x, 10 y, and then you have that line. And this is assuming we don't have this grid to reference, because we won't have this grid to reference unless we're using the grid snap, which is possible, but it's not going to be practical for large models. Okay, so just to reiterate, we can either put in dimensions independently and then choose our direction, or we can put in a relative coordinate system. Put in a relative coordinate, sorry. Okay, and then it's the same deal if we want to operate in the vertical axis. If we want to start drawing lines vertically, we can start doing the same thing, right? So 0, 0, 50. 50 is the z value. So we're just going straight up. Since it's a relative coordinate, it's just 50 millimeters straight up from the last point that we drew. Okay, and if we're using the single value kind of method, we can type in, this is what we can do. If we want to go vertical 50 millimeters, the other way to do it is we go to the last point we drew, hold control, and then click that point, and now you're moving only in the vertical axis, and now you can type in 50, and now you have your line. So that's the other way to do it. In a similar method to that, actually I already talked about the tab, the tab function, but it's super important, so I'm just going to talk about it quickly again. Click your line, hit tab, and now you have your white line, and you're locked into that direction. So it's the same thing that we just showed you in the last one. The last example, you're locked into the Z direction, but this, using tab, you can lock into any direction, right? You can lock into an angle. If you want to make something tangent, if I want to make a tangent line, I'm going to go here and I'm going to lock it to that direction, and now I'm locked in there, and I can choose whatever length, and I can either choose a point to lock onto, or I can just type in the length and make my line that way. So this is super important stuff to watch. So if you have to rewatch this, I would highly encourage you to just quickly go over this again, because these methods will make your modeling a lot more efficient. You'll get more done in less time. You'll be able to execute your vision a lot more effectively, and that's really what I want to see. Okay, so I think that was a pretty productive episode. We covered, the basics of what we need to do to start creating geometry. And in the next episode, we're going to talk about when we have that geometry, what are some methods that we can use to modify geometry that we already have? Because oftentimes, almost all the time, we don't start off with the geometry that we want. We have to build something and turn that into something else, and then maneuver that, so we have to understand how to properly modify geometry to get to that, the final place, the final geometry that we're looking for. All right, so I'll see you guys in the next episode. I hope you learned something in this one, and I'm out.